Welcome to Laws of Indices Level 2. Pause the video now, try the 5 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're simplifying 3x to the power of 7 multiplied by 6x to the power of 4 all over 9x to the power of 5. Starting with the numerator, we're going to use this law, which tells us that when we multiply indices together, we add the powers. So 3 times 6 gives us 18, and x to the power of 7 multiplied by x to the power of 4 becomes x to the power of 7 plus 4. Our denominator stays as 9x to the power of 5 for now. Since 7 plus 4 is 11, our numerator becomes 18x to the power of 11, and we can now simplify further. This fraction line means that we're dividing, so we're going to use this law, which tells us that when we divide indices, we subtract the powers. So starting with 18 divided by 9, we have 2. X to the power of 11 divided by x to the power of 5 becomes x to the power of 11 minus 5. And since 11 minus 5 is 6, our final answer is 2x to the power of 6. In problem 2, we're evaluating 2 to the power of minus 3. Because we have a negative power here, we're going to use this law, which allows us to write 2 to the power of minus 3 as 1 over 2 to the power of 3. And since 2 to the power of 3 is equal to 8, our final answer is 1 over 8, or 1/8. In problem 3, we're simplifying 3a to the power of 5, b to the power of 7, all raised to the power of 4. Since we're raising powers to powers here, we're going to use this law, which tells us that when we raise a power to another power, we multiply the two together. Now before we start, it's important to realise that the 3 at the start of the bracket has a power of 1 on it. And now we've realised that, we're ready to multiply. So we start by multiplying together 1 and 4, which gives us 4. So we have 3 to the power of 4. Next, we multiply together 5 and 4, which gives us 20. So we have a to the power of 20. And finally, we multiply together 7 and 4, which gives us 28. So we have b to the power of 28. Simplifying this, we have 3 to the power of 4 is 81, because it's 3 times 3 times 3 times 3. A to the power of 20, b to the power of 28. And that's our final answer. In problem 4, we're evaluating 3/4 to the power of 2. This means we need to find the value of it. So to start with, we can rewrite 3/4 as 3 to the power of 1 over 4 to the power of 1, all raised to the power of 2. Now this makes it really clear that to solve this problem, we're raising a power to another power. And so to do this, we have to use this law, which tells us that when we raise a power to another power, we multiply the two together. So starting with the numerator, we're going to do 3 to the power of 1 to the power of 2, and so we multiply the two together, and we have 1 times 2 is 2. Similarly, in the denominator, 4 to the power of 1 raised to the power of 2. To do that, we can multiply these two together, and we have 4 to the power of 2. Since 3 squared is 9 and 4 squared is 16, our final answer to this problem is 9 over 16. In problem 5, we're told that q to the power of n multiplied by q to the power of 7 all over q to the power of 4 is equal to q to the power of minus 2. And we need to find the value of n. Starting on the left-hand side and looking at the numerator, we can see that we're multiplying indices together. So we're going to use this law, which tells us that when we multiply indices, we add the powers. So we have q to the power of n multiplied by q to the power of 7 is equal to q to the power of n plus 7. And if we now write this in our fraction, we have q to the power of n plus 7 all over q to the power of 4 is equal to q to the power of minus 2. Now the fraction on the left hand side means that we're dividing the numerator at the top by the denominator at the bottom. And when we divide indices, we use this law, which tells us that we subtract their powers. So we now have q to the power of n plus 7 minus 4 using our law, and that's equal to q to the power of minus 2. If we simplify the left hand side, n plus 7 minus 4 gives us q to the power of n plus 3, and that's equal to q to the power of minus 2. Now, since the left and the right here are equal to each other, and they both have the same base, which is q, this means that their powers must be equal to each other. So we now know that n plus 3 must equal minus 2. We solve this equation by subtracting 3 from both sides, and we get to our final answer, which is n is equal to minus 2 minus 3, which is minus 5.